Welcome back to quantum computing. In earlier, we have studied about difference between classical gates and type of classical gates and what is quantum gate and what are the types of quantum gate and what is the mechanism of each quantum gate. Now, we'll go in depth. We'll try to understand how does each quantum gate works. So, in this lecture, I'll be explaining about the Pauli-X gate. Okay? To understand Pauli-X gate, it is quite similar to NOT gate. Okay, similar to NOT gate, but there will be a slight difference in the representation of X gate. Since we are working in quantum, X gate is represented in matrix. Okay, it is represented in matrix form. So, what happens in NOT gate? If you pass an input signal through our NOT gate, it will flips the value. So if you pass an input 1, it will result in 1. If you pass the input 1, it will result in 0. Okay. But what happens in quantum gate? We'll just go through an pictorial understand here. So first, input state. The initial superposition state is defined as. So in this example, they took the superposition state and they're applying X gate on superposition. So how we'll represent this? Since they have considered psi as our superposition state, the representation will be X oblique psi. If you are performing any gate operation, you need to write the gate first and then your input state. Okay. Then what happens in the output stage? The resulting state is flipped. You can see here alpha is having 0 and beta is having 1. Whereas in after applying the X gate, what happens? Alpha is having 1 and beta is having 0. So that is how the quantum X gate or Pauli-X gate works. Okay. And it is also called as bit flip gate. Okay. Good. But remember, if you are working on quantum gates, it is very important to understand its matrix representation. So without knowing the Pauli-X gate matrix representation, there is nothing to do with the quantum computing. So I'll explain about matrix representation and its working mechanism. Okay. Matrix representation. From now onwards, I'll be teaching the most interesting content. Even the subject will be little tough, but it will be very easy to understand. Please try to focus. Okay. Now, how we will represent this in matrix form? So, this is our X gate. This is how you will represent your X gate. Okay. If you are working on any simulators, suppose let's say in IBM, if you are working on IBM Quickset simulator, the X gate will be represented in this way. Okay. This is how the X gate looks. So, but coming back to the practical thing, X gate will be represented in 2 into 2 square matrix. Okay. 2 into 2 square matrix. This is how X gate is represented in matrix notation. So we'll work on a small basic example here. Here, initial state is a superpositional state. So we'll take the same example. Psi. This is our first step. Psi equal to alpha 0 plus beta 1. Okay. Now, what is the second step? We need to apply X gate. We need to apply X gate. So we'll proceed. X oblique psi is equal to X of alpha 0 state plus beta 1 state. Okay. Now we already know how to represent X. So it will be 0, 1, 1, 0 into, it is in superposition state. So how you will represent this in matrix representation? It will be 1, 0 and beta is, one state is 0, 1. Okay. Now what happens? 0, 1, 1, 0, 1, 0 plus again X gate 0, 1, 1, 0 into beta state. That means 0, 1. From here onwards, it is purely matrix multiplication calculation. Correct? What happens here? 0 into 1 plus 1 into 0 and 1 into 1 plus 0 into 0. Correct? Plus 0 into 0 plus 1 into 1. 1 into 0 plus 0 into 1. Fine. Till here it is good. Now directly you can write the answer. It will be 0. It will be 1 plus. It will be 1. It will become 0. But it is very important to represent the rows and columns. Here it is 2 cross 2 matrix. Here it is 2 cross 1 matrix. Correct? So it's what it will become? It will become 2 cross 1 matrix and 2 cross 1 matrix. Okay. This is how you will represent your quantum state after applying the X gate or Pauli-X gate or bit flip gate. Okay. So in next video, I'll explain about Pauli-Y gate. Pauli-Y gate. Until then, keep watching, like, share, comment, and do subscribe for interesting content. Thanks for watching. See you guys in next video.